Go ahead to get started.
Okay.
Okay, great. Hello, everyone. Welcome to the this session about aerospace engineering. And I know everyone, probably most of you have just attended the Dean, Assistant Dean's presentation. So here we're going to do a description, or basically overview of aerospace engineering department in the College of Engineering in San Diego State. First, a few words about myself. My name is Ping Lu. I'm a chair of the chair of the Aerospace Engineering Department. A quick background: got my PhD in aerospace engineering from University of Michigan. I teach and do research in aerospace guidance, control, flight dynamics, space flight. And here's my contact information, which can also be readily found in our department website. So let's say it's about myself. To start with this presentation, I think I'd like to give you a quick idea what is aerospace engineering. So first of all, aerospace engineering really as a profession is one of the major profession that supports overall in the US 2.5 million high-paying jobs. The average salary of an aerospace professional is typically 81% higher than the national average. It's a major pillar of the US economy. In California in particular, very few people probably are aware that the aerospace industry, in terms of its productivity and GDP contribution, is actually larger than both agriculture and entertainment industry combined. People think of California, they think Hollywood, and they think agricultural products. Actually, aerospace industry is bigger than both of those combined. So aerospace engineering in a nutshell is about anything that's made by people that flies, airplane, rockets, satellite, anything drone these days, and air taxi. So through this education, you will learn how airplane flies in the air, how strong these airplane rockets need to be, how to make them stronger if they need to be stronger, how to make them fly the way that we want them to. And so we deal with how to design a flying machine and how we can make them reliable and build them and maintain reliably and make them basically do things as we want them to do. Aerospace engineering, generally speaking, includes two major facets. That is aeronautics and astronautics. The aeronautics is about anything that flies in the air, airplane, drones, things that fly through the atmosphere. And then astronautics, that's about outer space, fly outside the atmosphere, on orbit to other planets. And aerospace engineering encompasses things that you learn in physics, mathematics, computation, experiments. That's why it's one of these fields that built on these fundamentals. Now these are these are some pictures of what they call the mostly aeronautics part of it. It's the planes, the vehicles, things that fly inside the atmosphere. You can see from your passenger airplanes to fighters to drones and to hypersonic planes, and to these days air taxi or the vertical takeoff vehicle. These are the vehicle that drives on the road and they can fly into the air, and they come at you sooner than you expect it. So the things that operate in the interface between air and outer space, like rockets, launch vehicle, these are the things that flies through from the surface of the Earth through the atmosphere to outer space, and we cover it. Then, of course, then you go to the outer space, you do planetary exploration, space exploration, and now the nation is geared toward sending astronauts back to the moon in the coming years, and ultimately, we really would like to land humans on Mars. And these are really the goals for space operations, space exploration, and we do it. We teach fundamentals on these sort of activity, what you need to do, and these are part of our curriculum as well. So exactly what we will study. Well, you will study aerodynamics. Aerodynamics is about understanding the motion of the airplane, when the airplane flies through the air, how it generates the force, lift and drag, and how you make the airplane more efficient and fly so that they can fly faster or quieter and use less fuel. And these are some things we teach as a major part of the curriculum, and we have several professors that have expertise in these areas. And the next areas you learn is propulsion. Whatever, be an airplane or rocket, you need to have some power plant to drive that thing, and that's where the propulsion comes in. You study the jet engine, turboprop, rocket propulsion, and how do you maximize fuel efficiency these days? It's critical how to the word is green aviation. How do you minimize the emission, etc. And again, we have several professors whose expertise are in these areas. They teach and do research in this particular area. Next one is structures. You will learn structures. These are the frames, the airframes that makes up the vehicle, be a rocket or spacecraft. And then you learn how to analyze the strengths of the material, strengths of a structure, design new material, optimize the performance of a structural design, how to make it lighter, how to make it the vehicle interact with the environment, like say air, so that it makes a more efficient plane, and how to design a lighter, a safer airplane and spacecraft. So we have professors whose specialty are in these areas. They teach and they do research in these areas. And then the next one is flight dynamics control, navigation, guidance. This is where I come in. And this is where you study how the force that acts upon a airplane, rocket, will make that vehicle fly the way you want. And how do you actually design a control system to make this airplane, rocket fly to achieve the goals that you want them to achieve, and how do you make them fly, for instance, to a distant location planet, use the least amount of propellant so that you don't have to waste a lot of these precious resources. So these are the things that they typically study in that particular discipline, and we have several professors, myself included, are in this particular area. Now, what I described are the general picture of aerospace engineering, and while we cover every one of these, and but the On the faculty level, or the program level, at the SDSU, we are this department, aerospace engineering at SDSU, has a long, excellent history. The department that came into being in the 60s, so we just celebrate about 60. Well, we are about 60 years old. And we are about one of the only 2 dozen or so what we call stand-alone aerospace engineering department in the U.S. It's not the entire U.S. There are other programs, what they call themselves aerospace engineering, but they're typically just a program in the department that houses several programs: mechanical engineering, aerospace engineering, etc. Aerospace is the name of the game. That's the only thing we do. So we are able to focus and devote all our attention and resources to aerospace engineering education. We have 12 professors, and we're supported by 8 lecturers. And I just mentioned the areas of extra expertise are covered. That are covered by the department that includes everything I just mentioned there. Some of the almost all our faculty, no, not almost all our faculty are very active in their professional activities, and some of them very well-known international leaders in their own field. And our department offers a close tie to local industry, government research lab, as well as on the national level. This picture is taken a few years ago, so it's only part of the faculty member we have, and we have grown since that was 4 or 5 years ago. So we have grown about 50% more than what was shown in this picture in the last several years. So why do you choose aerospace engineering program at San Diego State? And well, first of all, the excellence in our curriculum is nationally recognized, and as I said, we have 60-year history that exclusively devoted to aerospace education. And the curriculum provides fundamental knowledge as well as hands-on experience and prepare you for a lifelong success in your career. And we through various components of the curriculum and the research activity, we ensure our students have the basic knowledge, fundamental knowledge, as well as a practical skill to make them a productive member of the workforce from day one. Our faculty group of highly dedicated educators that really cares about education and student learning, and all of them are active in their research that help develop technology for the future. And their research, in turn, allows them to bring the state-of-the-art knowledge to the classroom to teach the students. And as I mentioned, we closely work with the industry, both locally as well as nationally. The location of San Diego is really, you hardly have a parallel, even in the US. It's a home, the San Diego as well as the Southern California is a home to many leading aerospace companies, the big ones, as well as many emerging new ones. And so opportunities are abundant for interaction with aerospace profession and learning directly from the profession. And we frequently on our all of our part-time lectures are the profession, the active profession. They work in government lab, in company, and they teach as well our students. So that's something that very few places in the country have this sort of advantage. The degrees that we offer in the department is really all the way from bachelor's degree to advanced degree. We offer Bachelor of Science in Aerospace Engineering. The picture you see here is a graduating class. I believe that's 2019. The one before we had in-person graduation in the before COVID. And but in addition, we offer Master of Science in Aerospace Engineering. We offer Doctor of Philosophy, PhD in engineering. This is jointly with UCSD, meaning that if you get into this program, you finish your PhD degree program, PhD degree, you will be a doctor from both. You will have a doctorate degree from both San Diego State as well as University of San Diego, University of California in San Diego. We offer a similar PhD degree in computation science jointly with UC Irvine. So this is an advantage that I think we are unique in the California State University system. I don't think there's any other campus in the US CSU system that is able to offer this full spectrum of a degree from bachelor degree all the way through PhD. We're the only one. And the question typically, our students would be interested in to know that where do our graduates go, and what are the companies that would hire your graduate? Well, here I have a partial list of the companies and the government labs that hire our recent graduates. You basically take a look. That's who is who in aerospace industry, and our alumni are some of the highly productive and recognized leaders in the industry. And if you look at I have several pictures here. If you know anything about the Predator, this is about the very first drone that the U.S. military ever flown, and it's still active in duty. This drone was produced or designed and manufactured by Northrop Grumman. The chief engineer, designer, and the team was former graduates of our degree. And we currently, as we speak, we have many alumni actively working in industry, government agency, NASA, and I got a couple of pictures here. This is a jet propulsion laboratory, and we have a big team of alumni from the San Diego State College of Engineering working there. And on this picture alone, there are two alumni from the degree from aerospace engineering. And I should mention that you heard you listened to Assistant Dean Garcia's presentation, and the YouTube video was by Anna Marino, who is an aerospace engineering graduate. And this was a picture taken roughly about a year ago. She was the system engineer that was at the control console the night before the Mars rover Perseverance landed on the surface of Mars. You see the clock there, 13 hours, 57 minutes. That's the time before touchdown. And that's the night when she was there controlling this multi-million spacecraft hurtling through the space toward Mars. That's where our graduates are working. Now, so I talked about all the classroom, curriculum program, and what about extracurricular activities? We have one of the most active extracurriculum activities group in the student activity groups in the university. Of course, we have this space, what we call Rocket Club. And I strongly encourage you to come to visit San Diego State on the Explore SDSU Day on April 9th. The Rocket Lab will be open, and you're going to get to see some of the things that the students get to work on there. These are the pictures taken 2 years ago, roughly, where they launched that Lady Elizabeth single stage liquid rocket. You heard the Dean Alovsky talked about that. That's the picture they taken right at the launch pad. This is where they recover this vehicle, and I noticed that the Dean did not show the video, so I want to show briefly a video that's taken on board of the rocket when it was launched. Just try to impress you. Okay, now the parachute is deployed, and I mean, the rule is that they need to recover the rocket. So that's when the parachute is deployed, and they went to they recovered the rocket. That's this picture shows. So that's really something. I mean, quite a number of our students are involved in this project, and that's been one of the highlights of our extracurriculum activity. So, oh, I'm sorry. This is on the rocket. On the airplane side, we have design, build, and fly. It's a it's a student project. Student really just this is a national competition. In fact, they participate every year. So they would design according to specification, required specification, a airplane or a drone, whatever that is in a particular year. Then they will actually go to a site, or the competing team will go to that site and fly test that vehicle, and has a competition going on. So that's a picture taken in some of the recent trips that they went, and they are going to participate just this month, I think, or next month, again this year to I think this is in Kansas to participate in that. So that's another very active group of students that is more on airplane, drones. And in addition, we have our students professional branch, the branch of our student aerospace professional society. It's called the American Institute of Aeronautics and Astronautics. And the students participate in those, and they get to visit various labs and companies, and they get networking opportunity to with the local professional or as well as a national level. The two pictures I'm showing here are taken this past January. They were at a national convention that happens in San Diego. It's called the AIAA SciTech. It's the largest professional meeting in this country in aerospace engineering. They were there, and they were there to present their papers. So these are our students, undergraduate students. They are presenting their papers at the largest aerospace professional meeting in the country, perhaps in the world as well. So at least in the Western world. So that's another part of the curriculum activity that extracurriculum activity our students actively are engaged in. So with that, I'm hoping I give you I have given you a overall picture of what aerospace engineering at San Diego State is like, and what at least the things is that you possibly can participate, and the education you can receive, and the interaction you would potentially have with some of the leading researchers and educators really in aerospace engineering. And our cliche is the sky is the limit. In aerospace engineering, this is really literally the case. So I'm hoping that this will give you some useful information, and I hope to see all of you in the fall of 2022. With that, I think I will stop, and I'll be happy to answer some questions that some of you have.
Dr. Liu, thank you so much. There is one question so far that I would prefer that you answer. And the question is, do we have a CubeSat program in our aerospace department?
That's a perfect question. And apologize for somehow leaving this out. Not particular a project, a student project per se. On the other hand, as an aerospace engineering student, you take all your courses, etc. And when you come to the fourth year, then every student will do a 2-semester, what we call a capstone design course. This is where you apply the knowledge that you learned in your coursework to the preliminary design of a space system. By that, typically it's either an airplane, spacecraft, or, as you might guess it, CubeSat. So we have had when you take this capstone design course, you would have an option to. We typically have 2 sections. One section focus on airplane, the other section focus on spacecraft, and you have the option to take that to be in the section of a spacecraft, and they have had project, and typically then the student will work in team, and each team will work on a particular project, and some of these projects have been CubeSat. So you do have that opportunity to work on CubeSat, and we don't have like a student club. Maybe you can start one. Okay.
We invite more questions, and we'll be here to address. Remember, Dr. Liu is here. He's the department chair. I will remain here on the call. And we also have still our admissions representative. And Dr. Liu, just to let you know, we have been answering some questions in the chat with regards to admissions, pre-major, and so forth. So yeah, they've all been answered so far.
Yeah, great. And by all means, either through chat, or if you, we still have some time here, and I kind of it's somewhat different every year. But in the past, I typically run my presentation 40-some minutes, and then I found out that there was not enough time to answer all the questions. So I decided to cut off a little earlier today and reserve the time to ask you to entertain questions. So by all means, ask any questions that you have in mind. If we know how to answer, we'll let you know. If we don't, we'll tell you we don't know the answer.
So a new question came in. Is there a freshman design project within our curriculum?
Okay. As a freshman, you're going to take a very first course in the aerospace engineering department. Is called the Introduction to Aerospace Engineering. It's AE 123. It's a 1-unit course. In that particular project, in that particular course, you will have some sort of a design, at this point, you don't have too much background or in aerospace engineering yet, but you're going to get your hands on. You can actually call that a design project. You're going to get a chance to work on a project where you actually not only design, you actually have to fly and you have to compete a glider. Okay, you will learn some of the basics about how to make things fly and how to stabilize a glider, and how to try to make that endurance fly longer. Then you apply those in that particular course, and you actually will start from scratch. Okay, and then you will then fly that in competition with your other. Then again, students will be working in team in competition with other teams, and at the end of a semester, we'll have a huge open field on campus. You go there, see who flies the farthest, or I think that's the competition's goal is who flies farthest. So yes, in that sense, you do have a small design project as your first experience.
Thank you. There's another really good question. Are there caps on getting into the major? In other words, can anyone who qualifies with meeting Impaction get in?
Teresa, you want to answer? You want me to answer that?
If you don't mind, I'll start.
Yeah.
So when a student is a pre-major, as soon as they finish the Impaction, they will automatically move into the major. So yes, in a sense, everyone gets in. If there are other students outside of the pre-aerospace major who want to get in, then there's also some different, well, they would also, of course, need to meet Impaction. And so far for us in AE now, we are able to take in students who meet the criteria to either change into, and definitely we prioritize our pre-majors. We'll get into the major automatically when they complete Impaction.
Yeah.
Hopefully that answers. And I don't know if you have anything to add, Dr. Lu.
Yeah, I think Dean Garcia sums it all. And we take in all the pre-major that satisfies the Impaction criteria. So in that sense, yes, everyone qualifies will get in. On the other hand, please pay attention to that Impaction criteria. That's something you want to really, from day one, you should have a laser focus to make sure that you work towards satisfying those Impaction criteria so that you can get in. These are hard requirements. There's no wiggle room in there.
Absolutely. And I have shared the Impaction card in the group, in the chat, so everyone has access to that. There is another question I saw. So for the capstone projects, do students from different disciplines work together? In other words, mechanical and aerospace, do they work together?
No, that's because each degree program, let's say aerospace engineering or mechanical engineering, will have their own capstone design course. So we don't, you only have aerospace engineering student in that capstone design course. That's because our degree program is credited. A credit program must satisfy a set of fixed criteria that set forth by the accreditation agency, and therefore these are the things that there are elements that you have to cover, and that students from other major may not have a background on that. So that the capstone design course is limited to each individual degree program.
We are all caught up with our questions. Thank you to everyone for your great questions. Thank you to the staff on the call who are answering those questions and helping us to do that.
Oh, yeah, there's a,
I don't know, Dr. Liu, because I was focused on the chat questions while you were talking. I don't know if you mentioned our Women in Aeronautics and Astronautics Club.
you mean the percentage of,
No, just the fact that we have a club, one of our student clubs, fairly new, but it is the Women in Aeronautics and Astronautics. It's a club.
oh, okay, that's super. Would you be able to share
Oh,
with?
of course.
Yeah.
Of course, I set myself up for that.
Yes.
So I did hear Dr. Liu say in his talk that if for the CubeSat question, if there was a project that or a club that a student that we didn't have already on campus, absolutely, students can start a new group. And that's in fact what these young ladies did. They are a group of young ladies who are in aerospace, and they started a club, Women in Aeronautics and Astronautics. And it falls under, because of the name and what they do and what they focus on, it falls under our aerospace engineering, department, if you will. And I'm just happy to report that they have had events where they've brought in women aerospace engineers to talk to the students. And so it's another just example of the way our students engage and the way that they can get leadership experiences, hands-on experiences, and so forth. So just wanted to mention that lots of things can happen here at SDSU.
Yeah, that's and this is one of the direction we really would like to work really hard toward, because we really would like to see more female students as general in engineering, but for me particularly in aerospace engineering, and that's really an exciting profession that we already have some alumni and graduates that are very successful female graduates, but we are very much like to see a lot more to come to join this exciting profession. So this organization is something that it's our latest, newest development, and not to sort of. I think this is also consistent to just last year, the year ago, 2 years ago, I think we just hired a professor, female professor in the department. That's the very first in our history, and so we're hoping this is just a start. All right.
I think there was a question that asked if we know our statistics on how many women are enrolled in our AE program.
Okay.
Yeah,
that's I don't know. Maybe Dean Garcia has exact number, but I don't have an exact number with me. We can find it out, but my we give you off top of my head, give you just rough estimate. I would say it's roughly 15% of our students are female students. That's obviously far from a desire, but that's one of the goals that we're working to try to improve.
So let's see. I did, while Dr. Liu was talking, I did look up our enrollment data for fall 21, and what I have found in aerospace, our undergraduate total is 501, and of that number, 83 are women. So I didn't do the calculation as far as a percentage, but you have actual numbers.
That's pretty close to 14%. So
wow. So you were almost on.
Yeah. Roughly, that I think my impression was is that in that range.
All right, great. Any other questions? Hopefully this has been helpful.
Yeah. Oh, good.
I think we have addressed all the questions so far.
All right. Anybody? Again, those of you, this is a virtual version, and in roughly about a month's time, uh, I hope to see all of you on campus. That's another 4 weeks from today. It's another Saturday. So many of the labs and the facilities in the college, university will be open, and weather should be nice. Really strongly encourage you to come to see the beautiful campus of San Diego State. It's one of those. We don't have a huge campus, but it's really unique and beautiful in its own right. You don't see many of those. Really, I've been at a few places before, and this is by far the most impressive, most beautiful campus. And you're going to get to see some of the labs. Our students lab. They work on their let's say rocket project, and then the teaching lab, teaching facility, and where they learn their hands-on experience. So that will be a good opportunity, and encourage you to take advantage of it.
Definitely. I put in the chat some of the details for the in-person Explore. So you'll see that it will be on Saturday, April 9th from 9 to 2.
Mhm.
Also, another reminder, there were several questions about the senior projects. And so just another reminder, I believe I also put in the chat the link to the Design Day archives so that you can see previous projects, you can see the exciting things. I'm so proud of our students. You can see the exciting things that they do from design, or from conception to design to prototype. And so our design day this year will be May 4th, 2022. If you happen to be in the San Diego area, please stop by. I don't know if we're going to have a virtual component to it this year or not, but please look on the website for more information and changing information. Dr. Liu, I'm not sure if you see in the chat, someone says they will be here actually on campus on Monday. Would they be able to stop by the department?
Yeah, you certainly can stop by the department. It's the the department, by the way, is in the main building of the College of Engineering. However, depending on when you are there, if anyone, if I myself or our department coordinator is available, we will be very happy to chat with you. But on the other hand, do note that I teach on Monday, and I have several meetings that I will be in and out, and the department coordinator may be with the other pressing matters. So if none of us happen to be there, then then we wouldn't be able to meet you. But if any of us is available, we'd be happy to greet you.
So you can try 3rd floor engineering building. Also 2nd floor is where my office is. But again, we welcome you. We want to try to support and meet your needs, but there is work that's, that's going on a regular Monday. So we will be happy to assist if we can. Any other questions? I'm going to drop one more link in the chat. It is the link to our Center for Student Success. Dina Levsky talked about it. I talked about it in a little bit more detail. Let me pick it up and drop it in the chat. So that you can take a look at it now, anytime in the next couple months. Maybe you're comparing it to someone else's information. We try our best. You can absolutely look at the department website, look at this video over again when it's available in the Explore page. And then I just dropped the Success Center website in the chat as well. And we break down information for students, for our students who are here to help them be successful. Yeah. I see Lindsay also just put some information in the chat and an email address for questions regarding admissions related questions. So just wanted to point you to some helpful information as you make your decision on what's the right fit for your family, for your student, which we hope is SDSU.
The looks like I got a couple of minutes, and most of the questions are addressed. Mm-hmm. So, just sort of as a concluding remark, I want to say a few words about. I touch upon that, but didn't spend too much time on that. But the availability of going for graduate degree at the San Diego State. Let me emphasize that somewhat. This day and age, to be an aerospace profession, you probably, the de facto degree expectation really is a master's degree. That's because the undergraduate degree gives you a broad-based fundamental, but once you start to work, then you'll find that you need that advanced knowledge, advanced training and skill set that to be successful in the professional field, advanced technology professional field like aerospace engineering. And you will find that practically all of your peers are either have already a graduate degree or they are working on one. So it is a de facto degree, that a graduate degree that's going to be required for people to work in aerospace industry. Now, therefore, it becomes so such a convenient and a readily available option in the department, where you can take all the way through and finish the graduate degree, and so people choose to stop and work first and then go back to school. That's choice. But if you decide to take it all the way through, then you do have that option. That's not available. Not everywhere is available. In fact, I think in most other comparable degree program in the CSU system, that's not an option that's available. If you want to do a master degree in aerospace engineering, you probably have to go somewhere else. But we do. Okay, we have the faculty, we have the facility, we have the system, a program that's been in existence, and all the way to provide you the education and the training all the way to PhD level, if should you want to go that far. But certainly master degree, and that's something that for anybody who chooses aerospace engineering, as a major really should start thinking. I know you think, I'm just a freshman and it's long away, but the time flies before you notice. So you want to plan ahead, and that's something that we have this capability not available somewhere else at least in CSU system. So that's something that I would like you to also think about. That 4 years really flies by fast, and whether or not that's something that will help you decide where to go. If you haven't decided, if you decided, that's that's great.
Thank you, Dr. Lu. We are at 11:51, I think, and there's no other questions in the chat.
All right, great. Then thank you for coming to San Diego State Aerospace Engineering presentation, albeit virtually. I wish everybody a very best and really hope to see you in the fall 2022. Have a good weekend. Bye now.